Hi, we are from ECM Group, and my name is Benedicta Elok, and my friends' name Kak Agnes and Kak Lo. And today we will present about electrochemical machining. Next. This is the content that we will present for today. The first one is introduction, the second one is benefit, and the third one is process, and the last one is advantage and disadvantage. Next. Introduction. Electrochemical machining, often referred as ECM, is a sophisticated and accurate metal processing technique, even though it has a complex and difficult design that cannot be processed in the conventional way. Electrically conductive objects can be processed with a degree of accuracy resulting from the ECM technique. ECM techniques are also frequently used in the automotive, construction, medical, and etc. Next. This is the products example that use ECM technique. The first one is automotive products. There is front wheel ABS hub. And the second one, from the pharmaceutical industries, there is rollers for the product tables. And the last one is steam turbines. There is steam turbine splits. Next.
The next part is benefits. As we know that the electrochemical machining has various benefits that settles on great decisions for machining conductive material. The first benefits are electrochemical machinings produce an excellent mirror surface finish. Why? Because there is no residual stress are produced. The second is less heat is generated in this machining process. Why? Because there is no contact between tools and workpiece. And the third is high metal removal rates. Means it's possible to cut even if cut small pieces. The fourth one is complex concave and curved workpiece. Means can be easily produced using the right convex and concave tools. For the functions, the first function that electrochemical process have is used to remove metals and alloys which are difficult or impossible to machine by mechanical machining process. The second function is uses both an electrolyte solutions and electrical current to alter the workpiece because electrical conductivity is necessary for electrochemical machining. The workpiece material must be conductive. The next. The next is about elements. The main parts of this electrochemical machining process are the first, electrolyte. As we know, electrolyte is an electrically conductive fluid. The second is cathode. Cathode is a tool. And the third is anode. As we know, anode is workpiece. And the fourth is power supply.
So now we are going to talk about the process of the electrochemical machining. So the first of all, the tool will start ejecting electrolyte from the reservoir. Then electric current start flowing. Negative charge is flowing through the tool, which is called cathode, and positive charge will start to flow to the workpiece, which now will be called as anode. As the electrical current is applied across the tool and workpiece, ions start moving between them. Now, for example, if we are talking about the workpiece as iron and we use NaCl as a solution, as the electrolyte solution, there will be a series of chemical reaction that is happening. At cathode, the hydrogen ion takes the electron that is released from the cathode to become hydrogen gas, while at anode, the Fe ion starts coming out as Fe2+. These react with chloride ions and form ferrous chloride, and with hydroxyl to become iron hydroxyl. while the sodium in the electrolyte reacts to the hydroxyl to become sodium hydroxyl. This ion will then combine with the hydroxyl ions from the electrolyte and precipitate or carried away by the electrolyte.
And the next is advantage and disadvantage. For the advantage of ECM, the first one is there is no direct contact between tools and workpiece. Therefore, there will be no forces and residual stress that is produced. And the second one is negligible tool wear. And the third one is less heat. And the fourth one is producing perfect surface finish. And the last one is that machinable materials can be processed. But there is also disadvantage that is produced. The first one is tool and equipment corrosion risk could affect the saline and acidic electrolyte of the products. And the second one is only capable for conductive materials only. And the third one is high power consumption, and then high cost, and the last one is environmentally harmful. Next.
So I guess that is the end of our presentation. And this is our reference. If you have any question, feel free to ask us in the comment. Thank you.